Okay, so we're going to treat a question on physics. It is supposed to be uh, a jam physics question. There is still a sense. So, so let us look at how much of the questions we can solve this night. Starting with question number one, that goes like this: that a solid weighs 0.04 Newton. That a solid weighs 0.040 Newton in air. So we have a weight in air to be 0.04 Newton and 0.02 Newton when fully immersed in a liquid of density 500 kilogram per meter cube. Let's say it's actually written 500 kilogram raised to power 3, which is wrong. It should be kilogram per meter cube as a density. So weight in air is this, and then the weight when fully immersed in water is 0.02 Newton. Then the density of the liquid is 500 given. That's the density of the liquid is 500 kilogram per meter cube. Calculate the volume of the solid. The question is calculate the volume of the solid. So the volume of the solid, and given the acceleration due to gravity to be 10 meter per second square. So this question, we have a particular solid. Now, a solid weighs this Newton, it has this weight in air, and when it fully immersed in water, then it has this weight, and the density of the liquid, when fully immersed in a liquid, not water, the liquid is not specified, in a liquid that has a density of 500 kilogram per meter cube. So you have to calculate the volume of the solid. So in this question, we are going to apply this Archimedes principle that says when a solid is immersed partially or filled in water, it displaces its own volume of the water. So when you immerse a solid in water, either completely or partially, of course, it is going to displace a certain volume of the liquid, which is said to be its own volume. And we see from the question that what the solid weighs in air is different from what it weighs in the liquid. So this is as a result of a force, the upthrust or the buoyancy a buoyant force acting on it when in the liquid. So it makes it to appear lighter in the liquid than its actual weight or than what it weighs in air. So if you are to calculate the volume of the solid, normally to calculate the volume, one of the relation or a formula that we can use is the density volume formula. That what density is mass all over volume. So if you know the density of the solids, which in this question is not given, the density given is that of the liquid. Supposing we know that of the solids, so we go ahead and we know the mass, then we can go ahead and substitute and get the volume. But in this question, we don't know the density, neither do we know the volume. We can say the mass can be obtained from the weight. There is a relationship between mass and weight. The weight is equals to mass multiplied by acceleration due to gravity. So already we have the weight given. We can actually get the weight from here. And to convert weight to mass, then we divide the weight by the acceleration due to gravity. So with this relationship, we could have gotten the mass, substitute here. If you know the density, then to calculate the volume. But we do not know the density of the solid. So most of the information as per the density we have here is for the liquid. Then the information on the weight is that of the solid. So if this is the case, how then do we go about it? So by applying the Archimedes principle, then like I said, there is an upthrust. It's a kind of a force in the liquid acting in the upward direction upon the solid. And this upthrust is equals to the weight of the liquid displaced. So, and how do we get this upthrust? The upthrust is simply obtained by taking the difference in the weight of the solid in air and in the liquid. So what are we saying? That upthrust is the weight in air. We assume weight in air is WA. Let's say weight in air is WA. Weight in liquid is WL. So weight in air minus weight in liquids is taken as the upthrust. So, and this upthrust equals the weight of the liquid displaced. What are we saying? That this equals the weight of the displaced liquid. So take note of this. If this is the case, then we're gonna go ahead and say the upthrust force equals WA minus WL. Then this is 0.04 minus 0.02. So this gives us 0.02 Newton, which is the upthrust. And we have just said that this upthrust that we have gotten is taken as the weight of the displaced liquid. Hence, the weight of liquid displaced is equals to 0.02 Newton. So, if that is the case, then the volume, like we have said by Archimedes principle, that the body, the solid displaces its own volume of the liquid. So which means the volume of the liquid that corresponds to this weight, the volume of the displaced liquid is equals to the volume of the solid. So which means if you're able to get the volume of the liquids displaced, then that also gives us the volume of the solid, because by the principle of Archimedes, when the solid is immersed in a liquid, it displaces its own volume of the liquid. So which means the volume of the liquid will be equal to its own volume. So if that is the case, then all we need to now do is to determine or calculate the volume of the liquid. And with that density volume formula we can use, because already we know the density of the liquid, and the mass can be obtained from here. We already have the weight of the liquid, which being equals to the upthrust. So what we do here is to convert to have the mass of the displaced liquid. So that mass will now be, like I've said, is the weight divided by 10, where 10 is the acceleration due to gravity. The formula we have applied here is weight all over acceleration due to gravity is equals to mass. So this is the formula we have applied there. And that should give us 0.02 by 10. It gives us 0.002 in what? In kilogram. So this is the mass of the displaced liquid. So we are not talking about the mass of the entire liquid, but the density is of the liquid is an intensive property of the liquid. It does not change with respect to the quantity of the liquid. It's not a volume dependent property. So that would have said, okay, if the mass of the displaced liquid, then we should also have the density of the displaced liquid, not the density of the entire liquid. No, density is what do I call it? An intensive property. It's a property that does not depend on the quantity of material that you have, the quantity of the substance. It's just like the boiling point of any liquid. So whether you have 10 gram of the 10 liters of the liquid or 1,000 liters of the liquids, of water, it is the same. This boiling point is the same as far as they have the same level of purity. So we've gotten the mass. Then we can now go ahead. We go ahead here to now calculate the volume from the density. So we know density is mass all over volume. So volume will be mass all over density. So on substituting, mass has been gotten to be 0.02002, and density is 500. So if you do that, 0.02 by 500, which gives us 4 times 10 raised to the power negative 5, in this case meter cube. So if we have to go by the values given in the question, then that should be the volume of the liquid, and which we also said corresponds to the volume of the solid, because this is one of the methods of normally used in determining the volume of an irregular solid. One of the methods. So like the use of the Eureka can, where you immerse the solid, then it definitely will push up some volume of the liquid. So this volume is collected and weighed, and that weight is taken as that of the solids. So this is how we need to go about it. So I hope this is understood. Like I said, this is the volume of the liquid. It is also the same volume of the solid. Going by the principle that says that the solid displaces its own volume of the liquid. So I hope this is actually understood. So um, so then we go to the next question. So the next question says a body of mass 5 kg starts from rest. A body of mass 5 kg starts from rest. So by starting from rest, what does it mean? It means the initial velocity u is 0 meter per second. That is what it implies. So that means it was not actually moving, but it was at rest. So its initial volume velocity is 0. It starts from rest and is acted upon by a force 1000 Newton. So it is acted upon by a force 1000 Newton. Then acceleration is the acceleration in meter per second square, and final velocity after 10 seconds will be the acceleration should be found. The final velocity should be found after a time of 10 seconds. So we take the question again. A body of mass 5 kg starts from rest and is started upon by a force 100 Newton. Then acceleration in meter per second square and final velocity after 10 seconds will be. So these are the parameters given to us, and we have to find the acceleration and final velocity after 10 seconds. So how do we go about it? We are definitely, this is a case of motion, and in motion, we have some equations we normally use in solving questions related to linear motions, such as the v equals to u plus at, the v square equals to u square plus 2as, the s equals to ut plus a half at square. I think we also have this average velocity multiplied by time. So these are the equations. Then because force is involved here and mass, then force is related to mass by this formula. Force is mass multiplied by acceleration. So we're going to use one or two of these to at least answer our question. We are looking for A and V at the same time, given mass and force and time. So if you are to substitute from here, we can find V. So but for us to do that, we need A. Time is known, U is known to be 0 initial velocity. So we need A, so we can't use that. The same way here, we have A and distance to contend with if you have to use it, so we can't apply this also. Then the same thing here, so we have no information on distance. Then though that such a distance can be calculated from here if you want to go that way, then substituted here with time, then acceleration can be obtained. But there is a better, an easier way of calculating the acceleration, which is from this, since we are given the force and the mass. So once you are able to get A, then we substitute here to get B, and that is all. So what you're going to do now, you're going to apply. So to find A, the acceleration. So we apply what? Force is equals to mass plus acceleration. So from here, our acceleration will be force all over mass. So where the force is given to be 1000 all over the mass 5. Mind you, we are making use of the information provided in the screenshot of the question I have here. So you might, in case none of the options corresponds to what our answer, then it is like I've said, there are some mistakes in some of the values. Maybe why you actually have 100, they write 1000 because it does not really matter what the values are there. What is important is for you to know how to know the procedure solving such questions. So by that now, if 5 goes into 100, that is 20. So we should have 200 Newton. I know 200 meter per second square. Meter per second square is the unit of acceleration. So this is our acceleration. So then the next thing is to find v. So to find the final velocity v, so we apply v is equals to u plus at. So from here, we can say this is 0, this is 200 t. So our time is given as 10 seconds. So we should have v equals to 0 plus 200, that's 2000, which finally gives us 2000. That is meter per second. So we can now say our A is 200 meter per second square, and our V is what? 2000 meter per second square. So as the answer. So that is understood. So the equations of motion is